So this is a bonus extension video if you find chi-squared analysis really straightforward and you'd like to develop your knowledge of statistical procedures. I'm going to go through an example of logistic regression modelling. Logistic regression modelling is the standard approach that we use to analyse survey data. I'm going to go through this quite quickly. It is actually relatively straightforward to do. So if you aren't following it, it doesn't matter. I've really just included this if there are students who find the chi-squared a little bit simplistic. So the reason that we want to do modelling is that with the chi-squareds, you can only compare two variables. So you can look at the relationship between interest in politics and climate change. You can look at the relationship between qualification, highest qualification, and climate change. And you might think, well, is there going to be an overlap between qualification and interest in politics? And it could be that what we're really measuring when we look at how much interest you have in politics and how that impacts on climate change, it might not be anything to do with politics. It might actually really just reflect someone's level of education. So in order to be able to look at these more complex relationships, we need to carry out multivariate analysis. So we need to be able to carry out a model of how different variables impact on the variable of interest, which in this example here is people's views about climate change. And that's what we use logistic regression to do. It enables us to look at how different variables interact and how we can control for the impact of one particular variable when we're looking at a particular variable of interest. But the easiest way for me to demonstrate what I mean by this is to go through an example. But there are a couple of limitations of doing logistic regression. Logistic regression is also known as binary regression. And in order to run this model, you have to have a binary variable as your variable of interest, also known as your dependent variable. Now, as you remember, the variable that we've been looking at, the climate change variable, has three values. Don't believe in climate change, believe in climate change but not caused by human activity, and believe in climate change caused by human activity. We can't run a logistic regression model with that variable as the dependent variable because it won't work. There are more complex models that we can run with a dependent variable of three or more values, but I'm certainly not going to show you how we do that because it gets a lot more complicated. So what I'm going to do instead in order to run a logistic regression model is I'm going to recode the climate change model. And I've already done this, so I've recoded the climate change model. Please excuse my spelling mistakes here, I was doing it quite quickly, but for illustration purposes it doesn't really matter. What I'm distinguishing is I've coded those first two groups together, so I'm distinguishing between those people who believe that climate change is happening due to human activity against those who don't believe that it's happening due to human activity, either because they don't believe climate change is happening or because they think that if climate change is happening, it's not caused by human activity. And for convenience purposes, I've coded it this way round. So this value, so the first value is climate change caused by human activity. You see, we know that's already 83% of the population, and the second category is just those other two categories combined. The reason I've reversed the ordering is that it makes the modelling a little bit more straightforward. But don't worry too much about that. But if you are going to run a logistic regression model, then I would recommend that you recode this variable this way around. The actual values behind this, I've set climate change caused by human activity as 0, and I've set no climate change for human activity as 1. So that's how I've recoded the climate change variable. For convenience, I've also recoded some of the other variables in the data set. So we've already looked at the recoding of how much interest you have in politics. I've recoded political party. You might not agree with what I've done here, but it's relatively straightforward. I've got Conservative, Labour. I've combined Liberal Democrats and Greens together, and in a political affinity with another party or no affinity is the 4th category there. I've recoded occupation. We have the variable on occupational classification, and I've recoded this into a binary variable. So I'm distinguishing between respondents who have a professional occupation and respondents, therefore, who don't have a professional occupation. They're working in either an intermediate, they're self-employed, or they're doing a skilled manual. So I've created a binary variable there. I've also created a binary variable for education, and I've distinguished between what for most people in the survey is that everyone who's stayed on into post-compulsory education. I know for many of you, compulsory education was extended to 18, but that actually for the population of the UK, that's a relatively recent change. So I've divided between A-level and higher, and GCSE or no qualifications. Another way of classifying that would be to distinguish those who've got a qualification and those who haven't. But for illustrative purposes, I've decided to combine A-level and degrees with, and then combine GCSE or no qualifications. I've also slightly recoded age group. I decided to keep the 18 to 24 on its own because it was looking a little bit different. I've therefore combined 25 to 54, and I've combined 55 and over. So I've recoded a lot of the variables in the data set, and that's the kind of thing you want to do when you're doing logistic regression, because the modelling gets very complicated, and it's going to be easier if we have variables that have fewer number of categories. So I'm going to show you how you run a logistic regression model. So I'm going to start off, obviously going to analyze, and this time I'm going to go down to the regression submenu here. And if you scroll down the bottom, you see there's lots of different kinds of regression modeling you can do. If you've done regression modeling before, you would have done linear regression modeling, but for linear modeling, we need a continuous variable. We don't have many continuous variables in the social sciences. So social sciences very rarely do linear regression. Sometimes I do linear regression modeling, but more often than not, I'm dealing with categorical variables. So I'm doing binary logistic. There are other ways of doing logistic that are more complicated, but we're going to stick with the most straightforward binary logistic. And the very word binary there will remind you that your dependent variable has to be a binary variable. So it has to be coded in 2 categories. So, this is the dialog box, and I realise I've already set it up from previously, so I'm just going to start off by doing a reset so I can go through all of the options for you. So the first thing I need to do is state what the dependent variable is. This is my variable of interest, and I'm going to put the recode of the climate change variable. I then have to choose my categorical variables. Now, I'm actually going to start at the top because the first one I'm going to put in is gender. I didn't have to recode that. That was already a binary variable. So I'm going to put gender in. And then at the bottom, I'm going to find all of my recoded. So I've got how much interest in politics, the age group, higher qualification, occupationals, and political parties. So I'm just going to choose all of those variables, and I'm going to put those in to the independent variable selection box. Now there's one very important thing I have to do before I continue. all of the variables that I'm using in this model are all categorical variables. The dependent variable is, but so are all of my independent variables. And I need to tell SPSS that these are categorical. If I don't, it will read them as continuous variables. So it will think that there is a meaning to 1, 2, 3. It will read them as a scale variable. And that's not going to work. So I need to tell SPSS that these are all categorical. So I'm going to click on the categorical box. I'm going to select all of these variables. If I just put my finger on the shift key and then click at the bottom there, I've selected all of them. Click them into the categorical covariate, so I've defined them all. The way this is set up, you don't have to worry about changing any of these details. I'll explain what those mean. It'd be easier for me to explain this through looking at the output. So all of my independent variables have been defined as categorical variables. That's all I need to do. I'm not going to make any changes to any of the settings. So I'm going to run the model. So here I have the output for the logistic regression modeling. There's quite a lot to go through, so I'll go through it. I'll go through all of the different bits of the output. Some are more important than others, and I will just highlight the bits that you really need to understand. The first bit of information we have is the case processing summary, which how many of cases were included in the analysis, and of those, how many have missing values. We don't have any missing cases for the dependent variable, the climate change variable, so no cases have been excluded, but some cases will have missing values for some of our independent values. So that's just showing us we've got some missing cases, but none have actually been unselected. So we see we have 2,940 cases included in the model. Then this is the dependent variable encoding. So SPSS does its own internal encoding of the independent variable, but I've actually set this up to mirror this internal coding. So the original value climate change caused by human activity is coded as 0, and no climate change through human activity is coded as 1. So this means that the model that we're going to be running is predicting whether someone is more likely to believe that climate change is not happening or it's not happening due to human activity than they believe that climate change is happening. So what I'm trying to do with this model is to identify the characteristics associated with people not believing in climate change. So my 0, my kind of baseline is believing in climate change. And I've set not believing in climate change or not believing that it's occurred through human activity as 1. So I'm modelling the probability that respondents are more likely to think that climate change is not happening or it's not happening due to human activity. So it's very important that you understand how this model is working. We are modelling the probability of someone believing that climate change is not happening, or at least not happening for human activity. So that's how the dependent variable has been encoded. SPSS then shows us how it's coded the categorical variables. All of our variables are categorical. In order to fit a categorical variable, we need to have a reference category. And the way that our modelling works is that we compare each of the other categories against the reference category. I'm going to actually start at the bottom here. It's easiest to explain this with a binary variable. So male and female at the bottom here. Male's been coded 0, female's been coded 1. So the value that I get in the model for climate change is showing whether women are more likely than men to believe that climate change isn't happening. Okay, so that's how a binary variable works. So if we look at the recode of occupational class, again, the variable I'm going to have in my model is going to show whether people in a non-professional occupation are more or less likely to believe that climate change isn't happening compared to professional occupations, which is coded 0. How much interest you have in politics? Again, we're looking at people with some or no interest in politics and whether they're more or less likely to believe that climate change is happening due to human activities compared to those who have a great deal or quite a lot of interest. If we look at highest qualifications, again, you can see the value is going to tell us whether people with GCSE or no qualifications are more or less likely to believe that climate change is happening due to human activities compared to people with A level or higher. Our last two variables actually have three categories. So here you see the reference category is being defined for age group as the youngest age group, so that's 18 to 24. So I'm going to have two values in the model here. The first value is for the age group 25 to 54, and this will tell us whether people in this age group are more likely to believe that climate change is happening compared to the reference group, which is aged 18 to 24. And again, for the value for the category 55 and over is again going to tell us whether people aged 55 and over are more or less likely to believe that climate change is happening due to human activity compared to the youngest age group. And if we look at what happens to our political party, which actually has four categories, again, the reference category here is Conservative, and we're going to be looking at whether Labour supporters are more likely or less likely to believe in climate change is happening compared to Conservatives, whether Liberal Democrats or Greens are more or less likely to believe that climate change is happening compared to Conservatives, or finally whether other or people with no political interest are more likely or less likely to believe that climate change is happening compared to Conservative voters. The next tables that we have in the output are less important. These classification tables are more important. This next classification table is more important if you're actually trying to use a model to predict an outcome. In the social sciences, we don't use models to predict. We're not medical scientists. We're not trying to work out whether a drug works. So that's why you might want to use a model to predict. We're more interested in understanding behaviours. So basically what this is telling us is that because by far the majority of people believe climate change is happening, this model is going to predict that people think climate change is happening. So don't worry too much about this. The next variable, the next bit of information is about what happens if we run the model with no variable. So that's what we might call the baseline. And then we enter all of our variables. We're using the simplest way of entering the variables, which is entering them all at once. I'm not going to show you other ways of doing that. Just do the enter all at once. And then this allows SPSS to be able to calculate how significant this model is. Again, don't worry too much about this. That R squared is okay. Again, because we're not trying to use a model to make predictions, rather explore behaviours. For social scientists, we're often not too worried about that. So I'm just going to tell you just to ignore that. What we really need to look at now is the very, very last table, because this actually shows us the model that we've generated. So I need to take some time to talk through this model.